Hello, 141ers. So you have a big reading assignment. It's only 2 chapters this week, but please make sure that you read them completely before you start doing any work. The assignment is ready to go. You'll see it at midnight tonight if that's what you wait up for. Otherwise, tomorrow morning. 3 things today. Number 1, cost synonyms. Number 2, where did marginal revenue and marginal cost come from? And 3, another market example, quantifying it step by step, and hopefully I do a little better job this time. All right, so let's start off with cost synonyms. So we have, in general, we can say that the only types of costs that we have are total, fixed, and variable, whereby my total cost is equal to fixed costs plus variable costs. And we define fixed costs as costs that happen because we're in business, not because we're producing something. So an insurance policy is a great example. You start a business and you have a liability policy in case someone is injured or hurt on your place of work. Whether you produce or not, the cost of that liability policy is there. And the more you produce, the liability policy probably doesn't go up. A variable cost is one that varies with output. And the more we produce, the higher that cost is. Fixed costs are also known as overhead. They're also known as ownership costs. And they're also known as indirect costs. Variable costs are sometimes called operating costs, and sometimes they're called direct costs. They have a direct relationship with output. They have a direct relationship with we're actually operating. Okay. We have some other costs as well, sunk and marginal. And marginal will check off part of number 2 as well, but we'll start with the sunk cost. A sunk cost is a cost that has happened that we can't recover. So it's not like seed that you purchased that you immediately decided you didn't want that perhaps you could recover the cost. It's something like, it could be something like depreciation. You buy a tractor and immediately it depreciates because it's no longer new. It could be utilities. We had utilities hooked up and we have electricity. There is a cost whether we use the electricity or not. Okay? If a cost is sunk in the short run, we should just kind of forget about it. And that's actually good advice personally as well. A good example of that is someone who drives a car that they keep sinking money into. No matter what they do, it just keeps breaking down. Maybe they paid $10,000 for it and they put another $6,000 of repairs. And they think, gosh, I'd love to sell the car. I hate it. It's a jalopy. It's not reliable, but I've got too much sunk into it. They know that the market value of the car is not $16,000. It's still 10 or even less. But what they should think of is this car is giving me a signal, a very strong signal, that it is a POS, a piece of excrement. You should sell it. Let someone else take care of it. You don't have to worry about ethics. You've fixed a whole bunch of stuff that's in it. Or maybe even a better example is you've been in line for a long time and you think, I can't leave the line. I've invested so much time in standing in this line already. But if the line's not moving, it's not going to continue to move. The signal that's being sent is that it is a slow line and maybe you should move to a different line or perhaps come back later. A marginal cost is a lot like a variable cost. I'm going to give you an example of a variable cost turned into a marginal cost. Let's say that the price of labor is equal to $10 an hour. And the marginal productivity, so the additional productivity or the additional units of output that labor produces, is 5. And let's say we're talking about sandwiches at Jimmy John's. The marginal input cost is the same thing as the price of labor. Now, this isn't in the textbook, but in class we add this on top, and we'll just kind of touch on it a little bit here. Marginal input cost, what's the cost of additional unit of input? Well, it's $10. But that doesn't tell me should I use it or not. I already know this information. Instead, what's the marginal cost per sandwich? If we're producing sandwiches at Jimmy John's, I can't just produce or define the cost of one more sandwich. I have to add inputs, and if that input is labor and it costs $10 and it produces 5 sandwiches, the marginal cost of each sandwich is $2. And we have this decision rule that says, hey, produce as long as marginal revenue is greater than or equal to marginal cost. Well, if our marginal revenue, which is the price, there we go, we got the rest of number 2 taken care of. As long as the price is greater than $2, keep on going. Maybe the next hour of labor, my marginal productivity falls to 3. Well, what's the marginal cost per sandwich? 10 divided by 3, $3.33. So the variable cost, labor is a variable cost. And marginal cost is related to variable cost, but instead we're putting it in terms of the unit of output. That should hopefully clear that up. All right, on to our last example, number 3, a market example, or our last learning objective, Let's say that demand for iPhones is 2,500 minus 3Q, and supply is equal to, 200 plus 2QS. We don't have to have decimals. It doesn't really matter. Now, I've been saying all along, hey, the left sides are equal to each other, so we can just force the right sides to equal each other. But if we actually put numbers on that, it might make a little more sense. It's kind of like saying 25 is equal to 100 minus 75, and 25 is equal to 1 million minus 999,975. So, mathematicians say, therefore, 100 minus 75 is equal to 1 million minus 999,975. Well, sure they are, because this is just like saying 25 is equal to 25. So here we know that P is equal to P. Therefore, 2,500 minus 3Q is equal to 200 plus 2Q. The kicker is only at this point. And that's why when we solve this, we drop the subscripts on the Q's. We just say we're talking about iPhones. That's the equilibrium Q star. This is the equilibrium price. We're going to force that Q out, and then we can solve for P. So 2,500 minus 3Q is equal to 200 plus 2Q. Now, if I do something to the left, I have to do it to the right. So if I add 3Q to get rid of this, because 2,500 minus 3Q plus 3Q, the Q's are just gone. Or another way to say that is move the Q's over here. It's equal to 200 plus 2Q plus 3Q. It's 5Q. And if I subtract 200 from this side, I get 2,300 is equal to 5Q. And if I divide both sides by 5, I get Q is equal to 460, I think. $2,300 divided by 5, 460. Okay, so this is 460. Now my law of demand tells me if I know my demand curve, if I know Q, it can tell me price. So it's saying At what price would 460 iPhones be demanded? So I put 460 in for Q. P is equal to 2,500 minus 3 times 460. Or P is equal to 2,500 minus 3 times 460, 1380. 2,500 minus 1380, my price, is equal to $1,120. Okay. Or I could have put this 460 back in to supply. And I should do that to check my answer because I'm doing this in my head and I'm a little bit nervous right now. P is equal to 200 plus 2 times 460. 2 times 460 is 920 plus 200. Sure enough, my price is $1,120. We got it. Okay, this is a short video today. I'll probably give you maybe 3 this week, 2 for sure. But make sure you read and have questions ready for Zoom tomorrow. Thanks.